Alright guys, today we are reviewing our chain rule, okay? So what I've written here in the blue box there is it's the formula for the chain rule. We learnt a shortcut using the chain rule back when we were first learning calculus. So we didn't really use this formula much, but I did say during the lesson, you may or may not remember, Extension 1 students, our shortcut method is great, but we will need to learn the actual formula eventually. So this is the actual formula, okay? And the proof to the formula is really straightforward, because if you have a look, we can see that the derivative of y with respect to t is apparently equal to the derivative of y with respect to x times by the derivative of x with respect to t. And if you look straight away, the dx will cancel with the dx, which gives you dy on dt. So it's easy enough to see. Now, that formula there can be manipulated among a variety of letters. For instance, that's why I've written or here. We could also say something like this: dy on dx is equal to dy on dt times by dt on dx. Because if you look there, same thing's going to happen. My dt will cancel with my dt, and I'm left with dy on dx, which is what the original part was. So the formula is not limited to those letters, okay? It works for any letter that you need in your certain question, as long as it works left-hand side equals right-hand side. So it's a pretty straightforward lesson today, because we're going to then use all of this in our next lesson in a more difficult way. But let's have a look at a few examples of how we can apply this understanding. So it says on example 1, calculate dy dt, given that y is equal to that, and that dx on dt is equal to 2. So first thing I'm saying is, all right, I need to calculate dy on dt. So I create my formula to represent what I want to find, which is going to actually be the exact same formula we have here, because all the letters we have is what we want, okay? So we could find dy dt if we take dy dx, which we could find because that's just the derivative of this function, because that's y with respect to x. And then timesing it by, well, what do we need to times it by to get rid of what we need? Dx on dt. And double check, yep, my dx will cancel with my dx, and I'll have dy on dt, which is what I need to find. So why do we do that? Well, because if you watch now what can happen, if I need to find If I need to find dy dt, I take dy dx. Well, if y is equal to x squared minus 2x, then dy on dx, so that's the derivative of y with respect to these x's, gives me 2x minus 2. So I substitute that in. 2x minus 2 goes in here, and that's timesing with dx dt, which I don't have to work out, they gave me was 2, which gives me an answer of 4x minus 4. So the derivative of y with respect to t is 4x minus 4. So we can find that without having an equation y equals in terms of t's. Okay, so we can find the derivative of whatever that equation is without actually knowing the equation, as long as we have enough other information. So let's have a look at another one, just to get your head around it a little bit more. I need to find dy dx. So if I need to find dy dx, well, I think to myself, okay, dy dx, that's what I need to get. What have they given me? They've given me an equation for y with respect to t. So I could find the derivative of y with respect to t, and then think, okay, well, what do I need to multiply by to get dy dx? Well, I need to multiply by a dt on dx. Because checking, yep, left-hand side would equal right-hand side. So let's see what I have. Dy dt, well, that's the derivative of this function here, because that's y with respect to t. So dy on dt is going to equal 2. So I put that in there. Now the derivative of t with respect to x, well, yep, that's t and it's got x's in it. So now dt on dx is going to give me 2x minus 4. So then putting that in gives me an answer of 4x minus 8. Now at this time, they don't want just what the equation is. They've said calculate at x equals 5. So now we've got our derivative. Now we just sub in x equals 5. So it's going to be 4 lots of 5 minus 8, which is going to give you 12, is your final answer. So that one, they just gave you a certain point that they wanted to know that rate at that certain time, or whatever they'd got x in terms of. All right, let's do one more and then I'll give you a bunch to practice. Okay, this one, we've got volume equals that, 4 on 3 pi r cubed. The derivative of r with respect to t is 4. We want to calculate dv dt. So straight away, I need to know dv on dt. What do I have? I have volume here with respect to r, and they've given me dr dt. So it doesn't matter what order I put them in if I start with this one. Now think, okay, what do I need to be multiplying by? Well, I need to get rid of the dr, so another dr under here, and dv. Because if I check, that will cancel with that, which gives me dv on dt, which is what they want. So now let's fill everything in. Well, dr dt is just 4. They told me that in the question. And dv on dr, well, that's what I need to calculate by differentiating that. If I differentiate that, pi is just a number, 4 on 3 is a number, so it's going to be 3 timesing by 4 on 3 pi r squared. My 3's will cancel, so the derivative is just 4 pi r squared. So 4 pi r squared, which gives me a final answer of 16 pi r squared. Then they want what that is, so that's, I'm going to keep labeling it, so that's what dv on dt is. And I want to know what it is at r equals 2, so at r equals 2, then dv on dt equals 16 pi lots of 2 squared, which gives me 16 timesing by 4 pi, which gives me 64 pi. And that's it. So sometimes I'll give you a value to sub in, sometimes they won't. But it's just about applying that chain rule formula with the information they've given you. So that's it for today. We're going to use that and jump up a fair bit in difficulty next lesson. But I want you to have a go at 8-11 today. I want questions 1 to 8 all done. So let me know if you have any questions and give it a go.